In this video, I will be solving a perfect square problem. Consider positive integer n with the following properties. 1/8 of n is a perfect square, 1/9 of n is a perfect cube, and 1/25 of n is a perfect fifth power. Find the minimum value of n. So, we have this number n, and well, since 1/8 of it is a perfect square, 1/9 of it is a perfect cube, and 1/25 of it is a perfect fifth, this means that it is divisible by 8, 9, and 25, obviously, because after dividing by 8, 9, and 25, you get integers of perfect square, perfect cube, and perfect fifth. So, let's write out the prime factorization of n. We don't know the exact one yet, but it can help us understand n better. So let n equal to, since it is divisible by 8, in the prime factorization, there must be a 2, since 8 is 2 cubed. So let the power of 2 right now be a. And since it's divisible by 9, the prime factorization has to be a 3 power. So it'll be 3 to the power of b. And since it's divisible by 25, there must be a 5 in it. So 5 to the power of c. And now we want the minimum value. So we don't want to add any other prime factors in it. Like 7, 11, it's just going to add and make the value of n larger. So right now you only have to consider 2 to the power of a times 3 to the power of b times 5 to the power of c. And now, let's start and use the given conditions. Since 1/8 n is perfect square, so 1/8 n equals to, this will equal to 2 to the power of a minus 3. This is because 1/8 equals to n to the power of negative 3. So 1/8 times 2 to the power of a will be 2 to the power of a minus 3. And then times 3b times 5c. These two stay the same. And then we can have that a minus 3, b, c are even by properties of perfect square. In the prime factorization, the exponent of each prime factor is going to be even. For example, 25 squared. 25 equals to 5 squared. And 2 is a factor, even. And if you take another bigger one that's not a prime perfect square, such as 64, 64 equals to 2 to the power of 6. Or we can also use 144. This will equal to 12 squared equals to 3 to the power of 2 times 2 to the power of 4. The even exponent just comes from the square because 2 times something is going to be even. Now, since 1/9 n is perfect cube, so we know that 1/9 n equals to 2 to the power of a times 3 to the power of, well, it's going to be b minus 2 since 1/9 equals to 3 to the power of negative 2. So 3 to the power of b times 1/9 equals to 3 to the power of b minus 2 times 5 to the power of c. And we can get that since it's a perfect cube, each exponent will be a power of 3. Will be a multiple of 3. So a, b minus 2, and c are multiples of 3. Now, since 1/25 n equals to 2 to the power of, no, since 1 over 25n is perfect fifth power, so 1 over 25n, we know that this one will equal to 2 to the power of a times 3 to the power of b times 5 to the power of c minus 2. Once again, 25 equals to 1 over 25 equals to 5 to the power of negative 2. So 5 to the power of c times 1 over 25 will be 5 to the power of c minus 2. And then a, b minus b, and then c minus 2 are multiples of 5. Since it's a perfect fifth power. Like for perfect fifth, 32 equals to 2 to the power of 5. And 5 is a multiple of 5, obviously. So now we can use this information to find the minimum of a, b, and c to get us the minimum of n. Okay, I'm gonna write it here. Since a minus 3 is even, a is multiple of 3 and 5, so obviously a minimum is going to be 15, since the LCM of 3 and 5 is going to be 15, and then 15 minus 3 is 12 and it's even, so this works. Now, since b is even, b minus 2 is multiple of 3, and b is multiple of 5. So, well, what is the least possible value that satisfies this? Well, this means that since b is even and b is a multiple of 5, b must be a multiple of 10. And, well, 10 doesn't work because 10 minus 2 is a multiple, it's not a multiple of 3. But 20 does work because 20 minus 2 is 18, and 18 is a multiple of 3. Lastly, for c, since c is even, c is multiple of 3, and since c minus 2 is a multiple of 5, you can get that c will be congruent to 2 mod 5. So c minimum would be 12. Because just check the multiples of 5. Will be like 5, 10, 12, 5, 10, 15, 20. So, well, 7 will be congruent to 2 mod 5, but 7 is not a multiple of 3. Now, 12 is congruent to 2 mod 5, and it is a multiple of 3, and it's even. So 12 is going to be the minimum of c. Now we have ABC minimum. You can get that n minimum will be 2 to the power of 15 times 3 to the power of 20 times 5 to the power of 12. And that is how you solve this problem. So the main point of this problem is that you have to just get n prime factorization and notice that it will be 2 to the power of a times 3 to the power of b times 5 to the power of c. And since it's asking for the minimum, there can't be any other prime factors, like 7 and 11. And then you have to notice the properties given, like perfect square, perfect cube, and perfect fifth. And then, using all this, you'll be able to find the minimum of a, b, c, and n. Thank you for watching.